when I substituted the 1 in there, right? When I took this 1 and plugged it in, that's when I stopped writing the limit. And that's when you need to stop writing the limit as well. Now, if you don't believe that we got this, I'm going to have the computer graph this for us. X cubed minus 1. Over, what was it, 1 minus x? And we were approaching 1. All right, I'll move this in so you can see it over here. I hope you can see that. So there's the graph in purple. We were approaching 1, weren't we? So here's 1. And we know at 1 what's happening. At 1, it's undefined. But as we come in from the left and from the right, what are we getting? We're approaching the same place. What is it approaching? Right here. This is -3, because that's -5. There's -3, right? And that matches our answer here. See, we could do it without the picture. We did it purely using algebra. Questions? You're gonna have to do a lot of problems to become comfortable with this.
So when we do this, we could use any formula?
Yep. Your algebra skills are now, you get to show them off now. Right? You get to see now, I'm going to do as many examples as I possibly can to expose you to as much algebra as I possibly can. But no matter how many problems I do up here, you're going to run into some algebra that I don't get to show you. I mean, that's just the nature of calculus. Like, it's algebra on steroids. What happens when I let x approach 0 here? Let's just try direct substitution first. Square root of 0 plus 1 minus 1 over 0. I already know it's bad because I have a 0 on the bottom, right? But let's just see what the top turns into. We get 0 over 0, right? 0 over 0 is bad. And according to what I just erased over here, I need to do some algebra or some sort of trick, right? Algebra trick. Do what? I'm sorry, I didn't hear you. Can you repeat?
Sorry, is that when we multiply by the conjugate?
Okay, yeah, so we have to look at this and do something, right? It's kind of like the lottery, right? You can't win the lottery if you don't play, right? You're never going to solve this limit if you don't try some algebra. You've got to do something. Now, the formula we used before this, right? The formula before this was the formula off the sheet. It was a difference of cubes, right? This one, there's no formula that's going to help you with this one. You just have to do something. And that's why it's important for me to be up here to show it to you, so that now you know to think of this. So whenever you see a square root involved and you have 0 over 0, whenever you see a square root, I want you to start thinking of the conjugate. Now, it may have been a while since you've dealt with conjugates, so what I'm going to do is just real quick show you what a conjugate is. So let's say somebody gives you two things being added together, okay? Then the conjugate of this is just those two things being subtracted. And it works the other way around. If you have two things being subtracted, the conjugate is just those two things being added. So it can go either way. So right now, in the numerator, do you see that you have the square root of something minus something? So we have like an a minus b. What would the conjugate be? Square root of x? I want another color. I guess I'll go with the blue. Yeah, we just changed that to a plus, wouldn't we? So when you see a square root, one of the tricks or algebra, ideas that you can bring in is the conjugate. Now, what do I mean by the conjugate? Like, what am I going to do with the conjugate? I'm going to multiply the top by the conjugate. But I can't just multiply the top by the conjugate. Whatever I do on top, I have to also do on the bottom. essentially what I'm doing is I'm going to be multiplying this by 1. But the one that I'm going to use is going to be very clever. The one I'm using is not written like that, it's written like this. It's the conjugate over itself. Isn't that a real fancy way of writing the number 1? Right? That's just a fancy way of writing 1. And remember, we can always, anytime we multiply something by 1, does it change? Anything times 1 is itself, right? So I'm taking this and I'm multiplying by 1. So technically I'm not changing anything. It's going to look different, but it's the same exact expression. Now, why am I doing this?
To get rid of the,
No, go ahead.
sorry, to get rid of the square root on top.
Because these are conjugates, the roots are going to go away. You'll see it in a second, but let me show you over here. If I take something, a plus b, and I multiply it by its conjugate, what happens if I take something and multiply it by its conjugate? Let's see what happens if you multiply these two together. What happens here? You get what? A squared. Okay, what happens here?
Negative AB.
Minus ab. What happens here? Positive ab. And finally, minus b squared. What happens in the middle? It cancels. So what winds up happening when you take something and multiplying it by its conjugate is that you get the a, you get it, that thing squared, and then minus the b, that thing squared, and all the middle stuff goes away. That's the beauty of the conjugate. So if I look at this right here, and I imagine that I'm going to multiply across the top like this and FOIL, if this is my a minus b, a plus b, I know that at the end, this is going to be squared, which means the root's going to go away. And I know that the 1's going to be squared, and 1 squared is 1. And all that middle crap isn't going to matter. It's going to cancel out. That's why I'm going to bring the conjugate in. If you didn't know to do that, now you know, like when you see square roots, start thinking conjugate. All right, here I go. Equals limit. X approaches 0. All right, this times this. A root times itself is itself, and the root's gone now, right? So that's just x plus 1. Okay, the middle ones, that one and that one, I'm not even going to do. Why? They should cancel out. That's the whole point of the conjugate, is that those will cancel. So all that I really care about now is this one times this one, which is minus 1. Okay, I'm done up top. On the bottom, do not multiply anything. Leave it all the way it is. The reason why I'm not going to multiply this and this together is because ultimately the problem that we were trying to overcome was this x, right? That was giving us the 0 down here. I would love it if this x canceled out at some point. And if I distribute it through here, it's going to start to get mixed up with all this other stuff, so I'm just going to leave it out front. So I'm going to leave the x here. I still have to have this, so I need to put that in parentheses. I'm just not going to actually multiply it through. Questions? Do y'all see what happens up top? One's cancel, which leaves you with an x, which is great because that x and that x will cancel, so long as I remember a little asterisk at the bottom that I can cancel them as long as x is never going to be 0, but I'm going to be approaching 0, so it should be fine. Let me go one more line before I actually do a limit. So I have an x on top, I have the x on the bottom, in parentheses, square root of x plus 1. And now those go away. I have a 1 on top. One more step. Limit. X is going to approach 0. 1 on top. I don't need the parentheses around this anymore because that x out front went away. And now I should just be able to do direct substitution. I should no longer have division by 0. So that goes in here, 0, no more limit, 1 over square root of 0 plus 1 plus 1, 1 over 2, 1/2. Square root of 1 is 1, 1 plus 1 is 2, 1/2. How are y'all feeling? I mean, I know you're following me and you're like, oh, this is good, but I mean, it's going to take you some time when you're at home to feel like comfortable with this. So we've done two problems that have required algebra, right? The first problem required a formula that we have on our sheet. The second one had a square root involved, and so we brought in the conjugate, right? So we have two kind of techniques up to this point. New problem. First thing, replace x with 2 and see what you get. You get 0 over 0, don't you? You get 1/4 minus 1/4 over 2 minus 2. So you get 0 over 0. This is bad, right? You could even put a frown if you like that. You can put a frown. But that, I know I need algebra trick, right? Algebra trick. All right, I'm not thinking conjugate. I am not thinking conjugate because I don't see any roots. The roots are what make me think conjugate, all right? The root is what makes me think conjugate. If I don't see a root, I'm not thinking conjugate. What I do see, though, is what we would refer to as a complex fraction. It is a fraction, right? But within it, there's other fractions. And anytime you see fractions within fractions, the rule of thumb here is to get a common denominator, to combine your fractions together. So I'm going to work right now on putting these two together into one fraction. And I'll do that on the side. To do this, I need a greatest common denominator so I can put them together. So 4x squared is the common denominator, so that means I have to take the fraction on the left, multiply the top and bottom of it by 4. The fraction on the right, multiply the top and bottom by x squared. If I do that, I'm multiplying each of them by 1, which doesn't change the problem, just makes it look different. But it allows me to have the same denominator. Right? I just put these together, multiply, I get that, and since they both have the same denominator, I can put it together into a single fraction. Right? So this is just another way of writing the numerator. Questions? All right. Limit x approaches 2. The blue box now becomes this right here. 4 minus x squared over 4x squared, but all of that is still over x minus 2. And now we still have a weird looking fraction, don't we? We have a weird looking fraction. I want to take another quick pause here. I'm going to write something on the board. I want you all to tell me what you think of this. What is that? I heard 6. So one person said 6, and then I heard what else? 12 over 8. Any others? 3 halves. Okay, let's see if I can figure out how y'all are getting these. I think I know where the 6 is coming from. Someone did 4 divided by 2. Right? What's 4 divided by 2? 2. What's 12 divided by 2? Okay, I get that one. 12 divided by 4, what's that? 3, and then 3 divided by 2 would be 3 halves, right? I understand those. 12 over 8, I think what happened there was maybe someone flipped a 2 up and hit the 4 with it or something? I don't know.
Once we have to do factor out the 4, it simplifies the 3 halves anyway.
If you factor out the 4.
It's 12 over 8.
Oh, you mean like do a 4 in here and a 4 in here?
I
No.
did something weird. I did something weird.
So look, we can't have different answers, can we? I mean, like, it's not the way an engineer would work. Like, you're building a bridge, it's like somebody's getting 6, the other person's getting 3 halves. So I'm doing this intentionally. I did something wrong intentionally. This is bad notation on my part. In order for me to make it where you get the same answer, everyone gets the same answer, I need to make one of these division bars longer than the other. So I have to, like, if I do this, that means you're going to do this first. And that would turn into 6. If I wrote it this way, now you do this first and then the 2, which would give you the 3 halves. Okay, so that the reason I'm doing that first is so you understand, like, the long division bar is important in mathematics when you have multiple fractions. That's the first thing. The second thing I want to talk about, so there was no correct answer, okay? This has a correct answer of 6. This has a correct answer of 3 halves. Okay, well, now that we've got that established, I want to do one more thing. If I take a fraction, long division bar, divide it by another fraction, so the fraction a over b, and divide that by the fraction c over d, division is the same as multiplication of the reciprocal, right? We learned that in college algebra. So this is equivalent to leaving the a over b alone and multiplying by the c over d flipped. And now it becomes d over c instead of c over d. Okay, we need these two things to proceed. You with me? Going to continue? All right. So back to this. Please recognize the long division bar. Right? There's your long division bar right there. I have a fraction on the top. And on the bottom, I have a fraction as well, but it's just a little hidden, right? X minus 2 over 1. That is a fraction. And that's still the same thing it was to begin with. So I have a over b over c over d. So I can rewrite this by flipping that one like that. And that's going to be my next line. I didn't want to do it without at least showing it once. It's going to be something I do frequently in here. So I have 4 minus x squared over 4x squared. That's the top fraction, I'm leaving it alone. But now it's times what? 1 over x minus 2. Yeah, we still have a problem, right? We still have an issue here. We have not fixed anything in this problem. We still have division by 0. Check for yourself. Let x go to 2. Isn't that still 0? It's still 0. We still have a problem. All we've done is just massaged it and manipulated it and made it look different, but we still need that x minus 2 to cancel. So this is where we have to see that that is what? A difference of squares. Again, more algebra, right? That's a difference of squares. That is, careful, because the 4 is in front, so it's going to be 2 plus x, 2 minus x. That's a difference of squares. And they almost cancel, don't they? Do y'all see that it almost cancels? Like this one, it's not this, right? This one's positive and positive, this one's positive and negative. So it's not that, but this one's real close, isn't it? Positive 2, take away x. This is positive x, take away 2. They're off by a negative again. So I've got to pull a negative out of anywhere I want, top or bottom, and then I can cancel things. The joys of calculus. So I'm going to rewrite this. Let me do it this way. Limit x approaches 2. This I'm going to leave as 2 plus x times this one. I'm going to pull the negative out of this one. It's negative 1. And then what would be left in there if I pull a negative just out of this? It would change the signs, wouldn't it? So it would be what? Minus 2 plus x, wouldn't it? Minus 2 plus x? And I could rewrite that. And that's all over, I'm going to put it all into one fraction now, 4x squared, and then times this, I have to put in parentheses. So I put those two together, push those two together. This times that is, 1 times that is just, 1 times that is just itself. I'm hoping that you see that these cancel now, right? Because I could rearrange the order, just flip it. Yes? No? Okay, where? Okay, so just remember that this right here, I could have rearranged the order and wrote that as x minus 2, couldn't I? Instead of negative 2 plus x, I could have written positive x minus 2, and then these two are exactly the same. But do you see how important it was that I pulled that negative out? Like if I leave it like this, they don't cancel. Because if I try and rearrange the order here, you see if I flip the order here, it looks like that. Those are not the same. I have to pull that negative one out first, then I can do the canceling. All right, I think I'm ready for the limit, but I'm going to write it one more time. Limit, x is approaching 2. Okay, on top, this was gone, right? This is gone. I'm going to put 2 plus x, and then I had a negative 1 next to it. And then over the bottom, which is just 4x squared now. I have eliminated the problem. The problem was that x minus 2 on the bottom, right? It's now gone. So now I'm going to let x go to 2 and see what happens. What do we get up top? 2 plus 2, 4. Negative 4 on top. And then on the bottom, we have to put 2 here first, right? 2 squared. 4 times 4, 16. And then I can reduce that fraction, negative 1/4. It's hard to gauge your faces whether or not this is just a long class or this is... All right, you're on your own. I'm going to give you 8 minutes to see how far you can get. And you know what? Make a friend. Y'all talk to each other. This isn't a quiz or anything. I just want to see if y'all can figure this out, all right? And there's more than one way to do it. I will say there's multiple paths to the correct answer, all right? Have at it. 8 minutes. Progress or no? Think you got something? I'm just looking to see what you did. Conjugate. Okay. Let's see. Did you get something? Got 12. Let me just see your conjugate. Yeah.
Plus square root of t, and then you got 4 minus 2, so you factor the t in this one right
Mm-hmm.
here. So you got 4 minus t on both the top and bottom, so I just factored them out.
Okay.
I got t.
I tell you what, y'all did basically the same thing.
Yeah.
You got different answers. Maybe y'all can look at each other and figure out. You got anything? You stuck? Okay, let me see.
I tried squaring the whole thing, but still.
Okay, so when you have a limit, you can't just arbitrarily square the whole thing, because what happens is you change what it is. You can only multiply by 1. So do you see on the bottom you have the 2 minus root t? You could use the conjugate and multiply top and bottom by the conjugate, but that's about all you could do in terms of manipulating it. You know what I mean? Okay, so maybe try that. You got something? Did you do conjugate?
Yeah.
You did? What did you get? What number did you get as an answer? You got 64, so we have 3 different answers. You got 4 or 64?
4.
4, 64, 12. You got 16. So this will be an interesting. Are y'all getting anywhere over there? Did y'all try? You're almost done? Did you do a conjugate?
Yes.
Okay. We'll work through it. I'm just going to see what you got. You got 16, you said, right? Okay. All right. Y'all talk about it. We'll go through it. You trying to conjugate?
So it doesn't matter if the square root is on the top or the bottom,
Doesn't matter.
as long as there's a square root.
Well, the conjugate is just we're trying it. We're hoping it's going to work, right? So if you're going to do the conjugate, the only thing you can do the conjugate of is the bottom. So you do it here and here, top and bottom, right? Okay. There's no guarantee it's going to work, but it's worth a shot. Did you try something? Or did you get stuck? Do you see the conjugate idea, though? You see that you have this, and the conjugate of it would be 2 plus root x. You could try that on top and bottom. I'm going to start working it up here silently, and then we can all talk about it, all right? Oh, by the way, was it 0 over 0? Y'all check that first, right? Okay, always check that first. I'm going to back up one step. The square root, where's it negative?
So that's where the answer.
I'm not sure where you're saying negative.
Never mind.
You sure?
I got 16.
You got 16. Okay. I'm gonna walk through this if anyone is interested in seeing one way to do it, and then I'm gonna show you a different way. So I guess the consensus here was that a lot of people wanted to do the conjugate, seeing that we had this on the bottom, right? And remember, ultimately we would love for this to go away, right? So if you're going to use a conjugate, you have to do the conjugate of that on the bottom, the top and bottom here, which I did right there. And now I'm going to multiply this and this together and this together. That I just wrote a different way right here. Now there's a crucial part right here. I decided to multiply this out, but not touch this. And the reason I did that is because the conjugate is supposed to make life better, right? And the conjugate multiplied together with the original expression, these two together is supposed to get nice. So I'm going to do that first and hope that something good happens. I'm not going to do this because it's going to complicate the problem by trying to multiply all that together. So when I multiply the bottom, 2 times 2 is 4. The middle ones I don't care about.